Hello, 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 everyone. I'm Fabrizio. Welcome to this intro to blockchain security research. I'm developer engagement at Urbit, and today we're diving into why security matters in smart contracts, especially for you engineering students in dependable distributed systems at La Sapienza in Rome. In fact, we are here at the university, and today we are gonna cover. We're gonna see some big hacks. We're gonna check some common vulnerabilities, how to spot them, and even a fun capture the flag challenge. So let's get started. Feel free to ask questions as we go. And first, a little bit about Urbate. Urbate is the biggest community of builders in person, of in real life builders in Italy, and one of the biggest community in Europe. So we have a Telegram group for discussions and also a physical co-working hub and where you can hang out, code, collaborate, build new projects, do a lot of fun things. We also have video games and everything. So we go there Monday to Sunday, 24/7, and we basically build relentlessly. So you're welcome to join and let's dive deep into it. Let's see about the agenda. So we'll start with why security research is crucial in the blockchain. Then we'll look at some of the most famous crypto hacks to see real world impacts. Next, the most common vulnerabilities in smart contracts. After that, tips on how to find those bugs and what to do when you do. Finally, we will play a fun and easy, very easy capture the flag exercise to put it all into practice. It hopefully should be fun and hands on, and feel free to comment. And especially if you are looking from YouTube, feel free to comment and tell me if I'm telling something wrong or I didn't get the point. You'll be very welcome. So let's dive deep into it. Why is security research so important? Let's break it down. Blockchain enables permissionless finance, right? Where anyone can participate without gatekeepers. But that immutability, once deployed, contracts in fact cannot be changed. So that immutability amps up the risk. A single hack can lead to irrevocable losses of funds. So, as engineers building dependable systems, or in general as software developers and blockchain developers, um, understanding blockchain security, not only coding best practices, but also um, how to, for example, make sure your private key is secure when you code or when you just use Web3 platforms is very important. So this is a bit of statistics. Just looking at the numbers, total losses from crypto hacks hit 3.8 billions in 2022, then dipped a bit and climbing again to 2.5 billions in 2025. So these bars show billions lost each year, and those billions are real money from real people. And so it this kind of stats highlights how critical security is in this space. Breaking it down further, here's a pie chart of major attack surfaces. So wallet compromises make up a whooping 70%, phishing 17, and code vulnerabilities about 13%. As engineers, um, think about how these tie into things like consensus and trust models. So yeah, so the point is that um, the weakest um, piece of the stack, it looks like the wallet. It's so easy to get your wallet hacked. Most of I never really get hacked, luckily so far. But my friends, all my friends, uh, all the people I know that got hacked, they got hacked because they somehow lost access to the wallet or they stole their private keys. So it's very important to be sure that your private keys and your password, your wallets are in a secure place, and you don't hold too much money on a hot wallet, let's say a MetaMask, in your browser. And yeah, and we will look into it deeper in. Um, so attackers exploit various weak points, right? So as we said, wallet seed phrases and keys. They try to steal your keys, as we already said. Then there is social engineering and phishing, classic spammy email. Um, yeah, telling that you received something, you need to click on this link, and then your wallet get hacked. Third-party integrations, maybe when you give permissions to a blockchain app to use your funds, and maybe this platform get hacked. Infrastructure misconfiguration. This is referred to the case when you are a developer, you're working on some project, and you somehow, maybe you use too much AI, and um, you just spoil your private key. That can happen, and this happen many times. And then there are bugs in smart contract, which is the topic that we're gonna look into today. And in fact, before doing that, I would like to show you the all-time Code for Arena white hat ranking. So Code for Arena is a auditing platform. So it's basically a website where companies post audits. So they do private audits. So the companies' protocols go to Code for Arena and they ask for an audit. And they also manage a competitive audit platform, right? So the competitive audit consists of it's like a contest, right? So you have this contest where people go and they can audit projects that choose to put their protocol in Code for Arena. There are many of these kind of platforms, and this is the leaderboard. So, for example, this guy, the number one, earned more than 1 million of dollars, and he found almost 1,000 bucks. That's crazy. And I also want to mention this number 10, Spearbit. They just found five bugs, but they earned almost 300,000 dollars. So this is to say that if you deep into this kind of topic, you can get rich. Um, the only barrier is time and effort. So you just need to put time and effort in that. Just need to put time and effort in that. And yeah, and you will be rich. It's just matter of time and effort. It's something that like everyone can do. You just need to spend time learning smart contract security and participate. You can start by following auditing a smart contract security course like the one from Cyfrin, and and then you can start with these competitive audits. Maybe you can also find a job in some audit firms. And so this is just yeah, for you to get inspired a little bit by this number. If you like being rich, and if you like coding, if you like programming, engineering, if you like solving problems, if you like solving problems, then maybe this is a good path for you. So now that we highlighted a little bit why security research is important, I would like um, to talk about the most famous hacks. Um, and the first hack I want to talk about is the Lubian hack. So Lubian is a mining pool that held 6% of Bitcoin's hash rate in 2020. And long story short, hackers stole 127,000 Bitcoins. And no one realized that until 2025. So Lubian used low entropy algorithms for private keys that basically were very, very easy to brute force with a decent computer. And so it's so funny because no one realized until 2025. They lost. They got stolen the equivalent of 3.5 billions of dollars in bitcoins, and that today will be worth 14 or 15 billion. We are talking about billions. That's so crazy. And this brings us to the entropy. So the entropy is the measure of randomness. So with that 32-bit entropy, there are about 4 billion possibilities um, to guess the private key, to guess a private key in this case, right? So it's actually doable. It's not that much, right? But if Lubian used the 256-bit entropy, basically the possible numbers of number of private key can be more than the estimated number of atoms in the observable universe. So it's basically impossible to crack the private key. And so this lead us to reason about the fact that security sometimes is not something crazy, but it was a silly mistake that Lubian people did, and and they paid a lot. Now the founders are disappeared, and they basically shut in 2021. At the time, China banned Bitcoin mining, and Lubian was a Chinese company, and it was operating also in Iran. And at the time, also Iran basically shut down mining because it was like Iran was lacking of energy, electrical, yeah, energy, and and so basically everyone thought that everyone thought that they shut down because of politics, right? but it's not, well, is not entirely true, because they got hacked. They kind of disappeared. They still hold 11% of their bitcoins. But on chain, you can see that Lubian employees send transactions with messages begging the hacker to return the funds. And to do so, they wasted 1.5 Bitcoin in fees. So they send like, I don't know, thousands of messages um, to the hacker, but the hacker doesn't have an email, so they had to reach to its address, and so they send transactions towards the address with this OP return opcode, and they're telling things like, please, 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 please get our money back, give our give back give give us back our money. It's so crazy. It's just so crazy. And then this leads us to the Bybit, the famous and also shocking Bybit hack. So Bybit is a famous centralized exchange, and basically the top management of Bybit was transferring 1.4 billions in Ethereum, and they basically did something called blind signing. So blind signing is when you sign a transaction without actually knowing what you're doing, and so everyone do it, right? Yeah, probably everyone signed the transaction sometimes without actually knowing what they were actually signing. And by that I mean, like, they probably, it happened to everyone that sometimes you sign a transaction knowing what theoretically you are signing, but maybe you don't know the exact call data bytecode that you're calling, right? And this is kind of hard to debug, especially if you're not an engineer, if you're not practical in the Web3. And it happened that top managers of Bybit um, basically signed a transaction on the safe wallet, and they thought they were signing a transfer of funds, but they signed a wallet upgrade. They signed a wallet upgrade, and they basically called a function uh, that drained the wallet. And the hackers also dry ran the attack 5 times beforehand. So it was already, the hack was visible on chain like 2 days before the actual big hack, but no one realized. They basically spoofed the front end. They made so that the Bybit signers will see a normal transaction, and they will sign this transaction to upgrade the wallet and call a function um, uh, called sweep ERC20. Let's see if I don't know, because I want to open this but I cannot open. Okay. um, yeah. So, and they just got drained. It's super funny and terrible. Yeah, I mean, for us it's funny, we're now talking about that, but for the people that signed that, probably wasn't that funny. um and then, yeah, what are the recommendations for that? So you can use end-to-end encryption for communications. You can adopt hardware security models for private keys. And but the most effective functions when you are transferring more than $1 billion maybe is to have a device which is dedicated to do this kind of transactions. So even if hackers um, manage to compromise your device, yeah, like your laptop or your phone or whatever, or your physical wallet, you just use another device, and they which you never use, right? So they don't have access to it, never, because it's rarely connected to internet, and so they basically their life is very it's basically impossible to spoof your safe front end app. And this is about running. This is the third use case that I will bring you today. So if you know Axie Infinity, you probably know Ronin. Basically, Ronin is a sidechain, an Ethereum sidechain made for making the game faster, to increase transactions per second in for the game. And so, as you know, Ethereum has a proof of stake consensus mechanism, and then maybe Bitcoin has a proof of work. They adopted this POA. They adopted this POA consensus model. It means that some nodes there were some nodes that were authorized to sign transactions. So basically, the story is that this company called Sky Mavis or Mavis were were owning four of these nine nodes that could submit transactions, and and the threshold to submit a valid transaction was five out of nine nodes. The point is that at that time, the DAO, the Axie DAO, give control of its node to Sky Mavis, and the hacker was able to break the Sky Mavis nodes, and so the hacker could submit um, a transaction on the running bridge, stealing 5k it. Okay, so they were able to exploit the breach by submitting a valid transaction and still 5k it. Probably was like, I don't know, maybe $700,000. So crazy. And yeah, this is also a centralized the attack vector is a centralized access control. Yeah, and it's very easy to avoid that, right? Just as I mean, it's not very easy, but the blockchain is should be decentralized, and in this case it was basically centralized, so it was kind of easier for the hacker to break this. And let's go on and let's dive a little bit more into code, and let's look at the most common vulnerabilities. I made here a checklist. You have, so I choose four. I choose errors in access control, reentrancy, oracle manipulation, insecure randomness. But for more, you can check this solidit. Solidit is a Solidit is a platform. I think it's done by Cypherin, and you have a list of things that you can check whenever you are building a smart contract. So when you're building a smart contract, you need to be very careful of security, because at the end of the day, if a contract gets hacked, then it's your fault. And I've been there in that position. I worked as a smart contract developer, and I can say that is tough. Is At the same time is tough, but also exciting, because you need to like take pay a lot of attention when you write code. You don't want to um, over trust AI, for example, because you want to like just check with your eyes that everything looks okay. AI is a great friend of you, but you don't want to just let the AI doing things right for you. And yeah, and this solidit is has, between the other things, a list of it has a list of things you want to check divided by topic. Like, for example, in DeFi, there is everything you need to check when you're writing, for instance, um, Flash Loan smart contract, or oracles. Everything you need to check when you are dealing with oracles. And this is helpful if you are writing code as well as if you are reviewing codes. So probably when you review code, um, you want to check this list. And let's go on. So let's go with the first one. You have here an error in access control. So you have a barn function that everyone can call, and then you need to put a modifier that checks if who calls the function has the right permissions. Another case, very famous, is a reentrancy. So basically, sending ether, or sending doing a transaction, or yeah, sending ether before updating balance, lets attackers call back and drain funds. So so well, not sending ether, but maybe doing external calls before updating the balance in this case, or before doing any updates in the storage of the contract, can lead to reentrancy. So reentrancy is happens when you recursively call a contract and you exploit it because the contract forgot the code, well, forgot to update the contract state. So in this case, we will call, for example, message sender dot call, and we will send a certain amount to this message sender. If the message sender is a contract that has a receive function, for instance, that call this withdraw function again, we will do it recursively until there will be no money in the contract left. So this is a very common vulnerability. Another one is Oracle manipulation. So if we look at the code, this borrow function trusts an external price feed without any check. So the attacker can flash loan, can use something called flash loan. So it's maybe borrowing money in the same transaction, borrowing and giving it back in the same transaction. Anyway, it can manipulate the price in a certain time frame, and can take advantage of this borrow function because there is no there is no boundaries for the price. So in the safe code, we have a borrow function with a price check. So we have a minimum price and a maximum price. So if the price is too low or too high, the function would revert because it means that there is something wrong. Another common vulnerability is about randomness. So using basically, there is something like, as you know, blockchain is a deterministic environment. So um, you cannot have randomness in the blockchain, because otherwise it's a bit complex to explain. But basically, if you say you have randomness, then you won't be able to validate and compute the state of the blockchain, because every time other people redo the calculation to get the same state to the same state of the blockchain, when they create a new block, you will never have the same result. This is just an example. Anyway, using block dot timestamps or similar variables to make random numbers is not actually random, and so you can be targeted if you don't use a secure source of randomness. And one solution is to use Chainlink verifiable randomness for having true randomness in games and lotteries. So yes, this is a common vulnerability. Again, this is just an entry point, right? So um, I'm not here to explain everything about all the vulnerabilities in the world, because it will be very time expensive, and um, probably you need to follow a good smart contract security course to do that efficiently. But this is just to make you excited and to have a broad idea of what vulnerability can look like. And let's go on, and we are gonna see what to do when we find vulnerabilities, and what to do after we find the vulnerabilities. So to find bug, you need to read the code, you need to scope the code, you need to understand what contracts you have to look at first, and then read the code, make maybe tests. Usually, when you write smart contracts, so when your role is a developer, you make a wide range of tests, right? You have basics one like unit tests. You can have integration tests. You can have FADS tests when you throw randoms values at your functions, and then you have invariant tests. So invariant tests are tests that check that a condition is always verified, no matter um, the order no matter whatever you do, the condition a certain condition needs to always be verified. For instance, an invariant test can be that I declare my contract, I declare myself, my address, as a owner of the contract, and the condition that should always be satisfied is that I am the owner of the contract unless I transfer the ownership. And to verify that this condition is always satisfied, basically I do a lot using invariant tests. And yeah, I do a lot of things. I do a lot of transactions. I test a lot of possible combination of transactions, and I see if these conditions is verified and satisfied always in all the cases. If I do an invariant test and I find that sometimes this is not satisfied, it can mean that this is an edge case I need to address in the code. So this is where you are writing the code. When you are reviewing the code, because you are a smart contract auditor, you want to check the code and you want to check the tests, and then you want to play with the code. You want to, for example, look at the checklist from Solidit to see that all the things are there. All the things in the checklist are actually respected. And yeah, and then if I'm a developer, I prepare the code for the audit, and then there is some auditor that check the code, and after maybe 1 or 2 weeks, uh, they submit a report, and the report contain the findings. So the findings can be critical, medium, or low, right? Can be high findings, low findings, depending on the likelihood to happen, and on the damage that they can cause to the protocol or to the contract. So if your contract risk to get drained, it's a critical issue you need to address as soon as possible. If your contract maybe doesn't get drained, but just you risk to lose, I don't know, cents of dollars, then it's not a critical finding, right? So they give you this report. If you're a developer, if you're auditor, you probably do the report. And to do the report, you need to include the proof, So you just you don't just point out this is a bug, you should fix it, but you actually make tests and you showcase you give a test case where your assumptions is true, so that you found that bug, that you can lose this money, these funds, and so on and so forth. So when they give you back the report, uh, you need to fix the errors, right. So if you didn't deploy the contract yet, that's good. You just upgrade the code. If your contract is already deployed and is in production, then you have two choices. So if the contract um, is a proxy, then you upgrade it. If it's not a proxy, then you need to deploy a new contract and tell your community um, that they need to just don't use not use that contract anymore, and then they will and then they will just not use this contract anymore. Probably they will withdraw funds from there, and so on and so forth. um, yeah, so you can also deploy without auditing at your own risk, and usually they do it when there is not much at stake. So if your contract doesn't really hold that much money, your company probably won't ask for an audit, because it's not worth, because an audit costs a lot. um, I don't remember. I cannot tell exactly a number of how much auditing company earns per hour, but it's in order of the thousands of dollars. So it's a lot. It's a lot. So probably this is you right now, but stick with me because we are gonna talk about uh, um, about how to fix the contract, especially specifically about proxy pattern. But first, what is a pattern? A pattern is a general reusable solution, which is commonly recognized or accepted. For instance, a pattern in life. I'm sad. What I'm gonna do? I'm gonna eat chocolate. In contracts, I need to fix a problem in a contract. After it is created, the solution is proxy pattern. And the meaning of proxy in English is, I looked it up the other day, and it is authority to represent someone else, right? It makes sense, right? So you have a kind of, let's call it, entry point of the proxy is a kind of entry point that leads to another contract, right? So you call the proxy, and the proxy somehow call something else, which holds some implementation, right? Some logic. And we have different kind of proxy, and today we're gonna talk about transparent proxy and universal upgradable proxy. Okay, so the transparent proxy is a pattern composed by two contracts. You have the proxy contract and the implementation contract. Um, you have an admin that can call special functions like upgrade, and um, the admin can only call admin functions, cannot call um, mm, business or business functions or logic functions. So the implement the so you have two contracts. We said the proxy contract and the implementation contract. The admin can only call proxy logic contract, so upgrade, and then other users can interact with the proxy, can use the logic of the contract passing by the proxy, and proxy has basically a fallback that has a delegate call to the implementation. What happens with the delegate call is that this specific special function execute the implementation logic in the context of proxy storage. So the storage is the memory, right? So the data of the in this proxy pattern are stored in the storage of the proxy, not of the implementation. So when you change the implementation, when you upgrade to V2, the data will still be persistent in the proxy, in this proxy. And this is the fallback that I was talking about before. So you have a fallback. Basically, all calls land here, and you have always a check if the message sender is the admin, and if it's not, we call the contract called delegate, which is then calling delegate call. So this is cool, but this is cooler. The transparent proxy, it's a bit tedious because it's more expensive and less efficient than the universal upgradable proxy standard, UUPS in short. Um, the In this case, there is just one contract. So opposite to the transparent proxy, where you have two contracts, here you have one contract, which holds the the upgrade logic. So the admin can call the upgrade logic. There is a modifier that check that who is calling is the admin, and then basically this contract inherit the UUPS proxy and has a storage slot which holds the implementation logic. Um, yeah, and and basically, yeah, it's very straightforward. So this is an example. You have the first V1 contract, which is inheriting all of this and is also upgradable. And so it has functions to upgrade the contract marked with the only owner modifier. And this is the V2. So in the V2, you can add things. So in this case, we added another storage variable and another function, and yeah, so it's just one contract. It's much easier to maintain, and the important thing is that the storage slot, which are spaces in the in the memory of the contract, are not overridden. So you don't want to, if you have in the V1, if you have value here, unit 256 public value, and here you have another variable like name. You don't want to delete this value variable, otherwise you're gonna lose the data. You're gonna break the proxy. Um, yeah, that's it. That's it. Those are the two main ways to upgrade the contract using proxies. And probably this is you right now, right? This is you a bit confused, and hopefully not. Hopefully not. If you have questions, doubts, if you think I didn't explain something very clearly, I'm sorry. But comment and let me know what is wrong, and if I can say it better. And now we have a capture the flag, which we will play in real life. So if you are on YouTube, you can just go to this repo and play the game. It's very easy. It's very easy. It's just four contracts that you need to exploit and drain. The funds are on base Sepolia. So probably this video will go out after the workshop is completed. So probably someone already exploited the contract. This was all from me. It was an extreme pleasure to to talk and to talk with you, to talk about smart contract security. We highlighted a little bit what is it, why it exists, how much money gets stolen every year. We looked at the measure hacks. We look at what to do when a contract get exploited, and now we have this CTF. I'm Fabrizio. Happy building and forza urbe. Goodbye.